Now we're going to talk about how to extend an extended regular expression into a DFA. So we're going to start by doing kind of proof by example. So recursion, let me tell you a little bit about recursion. Too few of you have studied recursion, but it's a program that calls itself. And what everybody's tempted to do is say, okay, I have this input, this calls this, which calls this, which calls this, which comes back and calls this, which comes back and calls, and then trace it out, and people get kind of crazy. So instead, I focus on, I have my inputs, and I can give an input to my friend as long as it's smaller and meets the precondition. They, by magic, give me the answer, and then I have the answer, which I have their answers, which I build my answer, right? That's how we're going to be doing it. But just for fun, I made more slides a couple days ago, in which we trace out an example. So here's the example, and we're gonna trace it out. All right. So our goal is that's our input is an extended regular expression, and the output is a DFA, which compute in NFA. I guess we're here we're converting to NFAs because the pictures are smaller, but eventually we're going to want to be converting these to DFAs, right? We know how to convert the DFA to an NFA already, so right. Everybody see what our goal is? So what we're going to do instead, it's a recursive program that calls itself. We ask friends for help. So what we're going to do is the guy here who has this input is going to break this regular expression into, well, it's the union of this and this. So let's get our friend to help us. We have a friend down here, and the friend's goal is to build a regular expression for this. So what is he supposed to do? What does he do? He says, oh, well, mine is this thing star. So I'll get a friend to build this thing here, and then I'll add the star on. And what does this guy do here? He says, well, this is the concatenation of four things, right? So he asks some friend, give me a DFA that can just accept one. Well, that's pretty easy. Here's a DFA that accepts one. It starts here. If you get a 1, actually, whenever I say DFA, mean NFA, right? Here's an NFA that accepts 1. Right? Everybody buy that? And now what about 0 star? Well, there's an NFA that accepts 0 star. Right? Everybody see that? And then there's 1, there's another 1, and there's another 0 star. So this guy, he had 4 friends. Each of his friends gave him an answer. And now his job is to take the answers that his friends gave, right? And he's going to concatenate them together. And when he concatenates them, it turns out it can. Here we got a 1 followed by 0 star followed by a 1 followed by 0 star. Now, if you were I cheated a little bit. I simplified as I wanted to go along, because really the formal definition of doing a concatenation is you put epsilon transitions between these, right? And that would have worked too. But otherwise the picture was getting too big, and I just simplified it. All right, so that's what this guy does. He has this input, and his goal is to produce that output. Right? So he's going to return that to this guy. And what's this guy going to do with his answer here? He's not going to study it too much. He's just going to take an epsilon transition from the accept state back to the start state and have a new start state that's accepted. Right? That's how you do the star. Everybody remember that? So if I want to star this thing, clingy star it, I take an epsilon transition from every accept state to the start state. That's this epsilon transition. So now, why is it? I can right? Instead of doing it once, I can do it many times to accept many of these things. Yeah. This outer star is what we're doing. This thing is for that, and we're adding the outer star to go up to here. Yeah. And this is an extra start state so we can accept the empty string. Everybody remember that? And this is reviewing what we did earlier in the thing. Right? Everybody remember how to do that? So now this friend says, hey, I was able to go from my regular expression to NFA. And then the top guy, he says, okay, great, let's go over down here and have another friend who is supposed to do A, B star. And he could go into his friends, but there's A, B star, right? And now this guy at the top, he says, I have a regular expression for this and a regular expression for this. So how do I get a regular expression? So I have an NFA for this and an NFA this. How do I get an NFA for the union? I just have an epsilon transition to get me my union. Right? Everybody remember that? So we can see how we use recursion here. Yes. Yes. Which previous one? The previous one. I do a lot of this here, right? I mean, proofs. We could, try to be more mechanically improving things, but hopefully I've convinced you that the NFA to DFA works, and then we're going to give this algorithm, and hopefully it'll convince that it works.
Oh, okay. What if that whole thing, the left union, right?
Mm-hmm.
That whole thing was in its own bracket with a clingy star?
This whole thing had a clingy star?
Yeah.
Well, then his boss would take this, and he would put an epsilon here, and an extra start state to go here. So this is another thing that's going to happen on assignments and midterms and stuff, is I give you a regular expression, and you're going to have to build something like this from it. All right? Now, on the assignment, if you look at the assignment, I had a regular expression, and I was going to get you to make an NFA from it, and then I was going to make you make a DFA from it, and I was a little panicked that if you did one of these steps wrong, that if you did the first step wrong, you couldn't do the second step, right? So that's why I turned it around in the assignment, is I give you this, and you have to look at it and come up with a regular expression, and you have to do, from this, you have to convert it to a DFA.
Having the initial state with two certain functions is the same as saying that the initial state is the exact same state, right?
No. In general, you don't want to do that because I want to take the union of something from here or something from here. I don't know unless you go in and study it that the empty set is in one of them. The empty is accepted, but only because I can follow this and accept. Empty happens to be in both of these, but the guy who's doing the union doesn't know that. Yes? Intersection was harder. We had to write everybody here this way, everybody in this guy the one direction, and everybody in this one in the other direction, and do the cross product. It was harder. Yeah.
What does assignment 2 do?
It makes you work.
No, what does it do?
Oh, when does it do? I was wondering about the existential meaning of an assignment. When does it do? It's due a week yesterday. It's due on the Monday, so we better we better get to proving the rest of these things soon.
Next Monday?
A week, yes. Next Monday. A week yesterday. Yes.
So we did, this is the proof for the union, right?
Yes.
So we're going to do the other stuff, the intersection.
We did them last class.
We did extended regulars and anything for that?
We did given an NFA and an NFA how to build the intersection and how to build the union and how to build.
Yeah, I remember that.
All right. So that was the algorithm. So there's the whole tree pointing out, right? And when you're doing, as I said, it's better to not focus on the whole process, but thinking each guy has an input. He has to produce his output. How does he do it? He gets help from his friends. Yes.
How is this example related to recursion here?
This was that's completely a recursive algorithm.
Is it like calling itself, like how is it?
We're going to write down the code now. So it's the program. We have a program that converts extended regular expressions into DFAs, and it's calling itself. Right? Right? It calls it on this friend and this friend, and then it merges the two. So this just says, how do you prove a recursive program works? Well, let S of n be the statement that the recursive program works on all inputs of size n. And then we're going to prove that it works on the base case, inputs of size 0. And then we're going to prove that for every input of size I, if it works for all inputs of smaller size, right? If your friends solve their instances fine on smaller instances, then the recursive program will work on instances of size I. So, and this is just the nature of a recursive program. Here's a program takes 3 inputs and it breaks them into smaller instances, and it gives those smaller instances to the recursive program, who gives an answer to the smaller instances, and then we have another smaller instance that we recurse on, and then we combine these two answers to get our answer. That's what a recursive program is going to look like. Everybody kind of follow that? Yeah.
Do you have like a question to this like program? Like what's the question and then you have like this program to solve?
Well, there's no question here. The question is, it's just showing you the structure of the program.
What are you trying to do?
I'm trying to show you the structure of a recursive program. All right, so if you want to know what a program's supposed to do, here's one that it's supposed to do. Right? What is a regular expression? Right? It can be all of this is a regular expression, right? It's a finite set containing finite strings. It is in itself is a regular expression. And then you can close it under union and concatenation and Clingy star. And for extended, you can include it under intersection and complement, right? And we've proven that we have closure under all those under these various things, right? And so now here, this is a recursive program that's going to take a regular expression, extended regular expression, and it's going to convert it into a DFA. All right? So the precondition is that R is an extended regular expression, and the postcondition is that M is a DFA that accepts the same language. Right? This is what we're supposed to write a recursive program for. And so we first start with the base case. What happens if we're given some regular expression, and what happens if it's a finite set of finite strings? Right? Can we build the DFA that accepts this finite set of finite strings? Right? We talked about how to do that. Right? So remember, any finite set of finite strings, so that's the typo there, has a DFA. And so let M be the DFA that accepts it, and we just return M, and we're done the base case. Everybody good with that? So now what happens if I'm given a regular expression, and it's the union, it's the intersection of two things, right? Maybe, for example, it's this intersect with that, right? How am I going to build a regular expression? How am I going to build an NFA for this? A DFA. How am I going to build the DFA for this? Right? I'm going to break it into these two pieces. I'm going to give this piece to one friend and this piece to another friend. Right? And those are smaller. So what are my friends going to do? They're going to convert these two regular expressions into DFAs. Right? Now I have two DFAs, and what do I do with those DFAs to get the intersection? Yeah, you run them in parallel, and you do the cross product thing. And this says that DFAs are closed under intersection. So we just use that fact. Right? He says, don't micromanage me. Don't tell me how to do my job. I'm going to just give you the answer. Right? So, and then we see it's closed. So we take these two DFAs that were given to us, and we build a DFA that does the intersection, and we return that, and we're done. Right? Everybody buy that? And the same for union. Right? And the same for complement. Right? Everybody see that? Now what about for concatenation? Right? Again, we get help from our friends. Our friends give us regular expressions. Right? But what can we do with those? Can we just convert them into, do we have a program that does this? No, we don't have a program that does this. Right? So what do we do instead? Right? Instead, we convert it into an NFA. Right? And then we convert that DFA into an NFA into a DFA. Right? Everybody good? All right, so I'm given a regular expression, which is the concatenation of two other regular expressions. What am I going to do with them? I'm going to get my friends to make DFAs for them. And then I don't know how to combine two DFAs to get a concatenation DFA, but I do know how to combine two DFAs or NFAs to get an NFA. Right? So that's what I do, is I convert my two DFAs into a concatenation, an NFA that does their concatenation. Right? Now I have an NFA. And then we do our GNOME thing to convert our NFA into a DFA, and we're ready to go home. And we return that. Everybody get that? And then, of course, the same is true for Clingy star. Right? We get our friend to convert this regular expression into a DFA that does R1. And then we don't know how to get a DFA of a Clingy star, but we do know how to get an NFA out of a Clingy star. Right? So we get an NFA out of this thing. And then we could convert our NFA into a DFA. And that is all the cases. Everybody good with that?